Hello and welcome to today's webinar on generative AI for autonomous IT. So, the first slide is about what is generative AI. Generative AI refers to a class of artificial intelligence technologies capable of creating new content such as text, images, audio, code, or simulations based on patterns learned from vast datasets. It uses advanced machine learning models, particularly large language models, LLMs, and generative adversarial networks to understand context, replicate styles, and produce outputs that closely resemble human creativity. By learning from diverse data sources, generative AI can generate realistic content, answer complex questions, and assist in sophisticated problem solving tasks that once required significant human effort. Generative AI enhances productivity by automating creative and knowledge intensive workflows. It helps organizations produce marketing content, design prototypes, draft legal documents, and generate code snippets in seconds. This reduces manual workload, accelerates content creation, and allows teams to focus on innovation and strategy rather than repetitive tasks. Through natural language understanding, generative AI supports conversational interfaces, enabling human machine interactions that improve user experience and accessibility. Real-time reasoning capabilities allow generative AI to provide intelligent recommendations, optimize business processes, and support decision-making with contextual insights. When integrated with enterprise systems, generative AI can analyze operational data, produce detailed reports, and highlight trends or risks that might otherwise go unnoticed. Predictive text generation, automated summarization, and intelligent search functions enhance knowledge management across the organization. In software development, generative AI accelerates development operations and CI and CD workflows by generating boilerplate code, identifying bugs, optimizing functions, and suggesting architectural improvements. It supports rapid prototyping, reducing time to market for new applications. Its adaptive learning mechanisms continually refine refine output quality based on feedback, improving accuracy over time. Security teams benefit from generative AI's ability to detect anomalies, simulate attack scenarios, and generate threat intelligence reports. By understanding patterns in cybersecurity data, generative AI strengthens defenses and improves incident response strategies. In customer service, AI powered chatbots and virtual assistants deliver personalized 24 by 7 support, improving satisfaction and reducing operational costs. Generative AI significantly enhances creativity and design. It assists artists, writers, game developers, and designers by generating concepts, visual assets, storylines, and blueprints tailored to project needs. In scientific research, it accelerates discovery by generating hypotheses, modeling molecular structures, and simulating complex systems. Healthcare applications include generating clinical summaries, assisting radiology workflows, and enabling personalized medical insights while maintaining data privacy through synthetic data generation. Across industries, generative AI enables scalable automated content pipelines that align with business objectives. Its ability to integrate with cloud services, data platforms, and enterprise applications make it a foundational technology for digital transformation. Organizations adopting generative AI gain operational efficiency, reduced costs, enhanced innovation, and faster execution cycles. By 2025, generative AI is becoming indispensable not only for creative tasks but for strategic decision making, automation, and competitive advantage. Traditional manual approaches to knowledge work cannot keep pace with modern digital demands. Generative AI transforms businesses into proactive, data driven enterprises capable of rapid adaptation. It empowers teams with intelligent tools, fosters collaboration, and unlocks new opportunities for innovation. With continuous learning, scalable architectures, and growing multimodal capabilities, generative AI serves as a catalyst for enterprise wide growth and long term digital resilience. Now, the next slide is about why generative AI is critical in 2025. Generative AI is critical in 2025 because the pace of digital transformation has accelerated beyond the capacity of traditional tools, requiring intelligent systems that can create, reason, and adapt in real time. Organizations face unprecedented complexity in their data ecosystems, and generative AI provides the advanced capabilities needed to manage, interpret, and utilize this information effectively. With businesses operating across cloud, on premises, and edge environments, generative AI becomes an essential engine for unifying data, streamlining workflows, and enabling rapid decision making at scale. Its ability to generate high quality content, automate tasks, and provide contextual insights allows enterprises to maintain agility in a marketplace defined by constant change. As customer expectations rise, generative AI delivers personalized experiences that would be impossible to achieve manually. It supports conversational interfaces, dynamic content generation, and intelligent recommendations that enhance engagement across digital platforms. This level of personalization is crucial in 2025 as organizations compete not only on product quality but also on the responsiveness and adaptability of their customer interactions. Generative AI bridges this gap by understanding user intent, predicting needs, and delivering tailored solutions instantly. The technology is also vital for addressing the growing skills gap. Many industries struggle to keep up with the demand for specialized talent, especially in fields such as software development, cybersecurity, and data analytics. Generative AI acts as a force multiplier, enabling teams to accomplish more with fewer resources. It automates coding, supports troubleshooting, and assists with architectural decisions, allowing developers and engineers to accelerate innovation and focus on higher value problem solving. In sectors where expertise is scarce, generative AI ensures continuity, efficiency, and faster execution. Cybersecurity threats in 2025 are more sophisticated, frequent, and automated than ever. Generative AI plays a crucial role by analyzing massive volumes of threat data, simulating attack patterns, and identifying anomalies in real time. Its predictive capabilities allow security teams to stay ahead of attackers, enhancing resilience across digital infrastructure. Automated threat intelligence generation and proactive detection mechanisms give organizations the defensive strength required to operate safely in an increasingly hostile cyber landscape. In research, healthcare, and engineering, generative AI accelerates discovery by modeling complex systems, generating hypotheses, and providing simulations that reduce experimentation time and cost. This is especially critical in 2025 as industries strive to innovate faster while managing rising operational demands. Generative AI supports precision medicine, drug discovery, and clinical decision making with unprecedented accuracy, helping healthcare providers deliver better outcomes and personalized care. From an operational standpoint, generative AI ensures consistency, quality, and scalability across business processes. Automated document creation, workflow orchestration, and knowledge extraction reduce bottlenecks and eliminate human error. Organizations that rely on manual methods struggle to keep pace with increasing workloads, but generative AI offers the scalability needed to maintain performance under growing demand. Its integration with enterprise platforms, ERP, CRM, ITSM, and more creates unified intelligent systems that optimize operations end to end. Generative AI also enables real time strategic decision making, supporting leaders with data driven insights, simulations, and forecasts. In a world where market conditions shift rapidly, companies must be able to evaluate scenarios and respond immediately. Generative AI's ability to synthesize data, generate reports, and surface actionable intelligence provides a competitive advantage that traditional analytics cannot match. By 2025, the global economy is deeply interconnected and digitally dependent, making adaptability a key determinant of success. Generative AI drives this adaptability by offering continuous learning, multimodal understanding, and dynamic content generation that evolve with business needs. It empowers organizations to innovate faster, reduce operational friction, and deliver superior value to customers. Ultimately, generative AI is critical in 2025 because it transforms businesses from reactive to proactive, from manual to automated, and from data rich to insight driven. It acts as a foundational technology that supports growth, enhances resilience, and enables organizations to compete and thrive in an increasingly digital world. Now, the next slide is about generative AI for autonomous IT operations and systems optimization. Generative AI is emerging as a transformational force in autonomous IT operations, enabling systems to predict, prevent, and resolve issues with minimal human intervention. By leveraging large language models and advanced generative algorithms, organizations can automate complex IT workflows, generate real-time insights, and optimize performance across cloud, on-premises, and edge environments. Generative AI brings the capability to interpret system logs, configuration data, infrastructure metrics, and operational patterns to create actionable recommendations that improve efficiency and reliability. In autonomous IT environments, generative AI enhances observability by synthesizing data from monitoring tools, service dashboards, and event streams. Instead of manually searching through logs or alerts, teams receive AI generated summaries that highlight root causes, performance anomalies, and emerging risks. This accelerates incident response, reduces downtime, and ensures that critical services remain stable even under unpredictable workloads. Generative AI augments traditional monitoring by providing contextual explanations that make troubleshooting faster and more accurate. Generative AI also revolutionizes predictive maintenance by modeling system behavior and forecasting failures before they occur. It identifies resource bottlenecks, degraded components, and performance trends that would be difficult or impossible to detect manually. These predictive insights help IT teams schedule maintenance proactively, optimize capacity planning, and ensure that systems maintain peak performance across dynamic environments. Automated remediation workflows allow issues to be fixed automatically, preventing service interruptions and improving service delivery. In optimization scenarios, generative AI analyzes compute, storage, network, and application utilization to recommend or execute intelligent adjustments. It generates optimization strategies for load balancing, auto-scaling, and resource allocation based on real-time demands. This level of automation enables organizations to reduce cloud spending, eliminate waste, and improve energy efficiency. Generative AI driven orchestration ensures that hybrid and multi cloud environments remain aligned with business policies and performance requirements. Within development operations and CI and CD pipelines, generative AI accelerates deployments by generating tests, identifying code vulnerabilities, and predicting deployment risks. It automatically evaluates changes, analyzes dependencies, and ensures that updates are deployed safely and efficiently. By generating infrastructure as code templates, documentation, and configuration policies, generative AI improves consistency and reduces operational overhead. This integration enhances agility, shortens release cycles, and reduces the likelihood of deployment related outages. Security operations are Security operations are strengthened as generative AI detects anomalies, simulates threat scenarios, and generates real-time incident incident intelligence. By analyzing behavioral patterns, access logs, and threat indicators, it provides early warnings and recommended actions to mitigate risks. Automated threat modeling helps organizations build stronger defenses and respond faster to emerging security challenges. Generative AI ensures that IT ecosystems remain compliant, secure, and resilient. For IT service management, generative AI automates ticket handling, knowledge retrieval, and workflow execution. It interprets incoming requests, generates accurate responses, and even executes backend actions to resolve common issues autonomously. AI generated runbooks and resolution summaries improve knowledge sharing and reduce the dependency on manual support processes. This leads this leads to faster resolution times, reduced support costs, and higher user satisfaction. Generative AI also enhances data driven decision making. It synthesizes operational intelligence into executive level reports, translating complex technical data into insights that guide strategic planning. With the ability to evaluate thousands of scenarios and optimize configurations dynamically, generative AI empowers IT leaders to make informed, proactive decisions that align with long term organizational goals. By 2025, the scale and complexity of IT ecosystems require systems that are adaptive, autonomous, and self optimizing. Generative AI delivers these capabilities by combining automation, predictive analytics, and contextual understanding into a unified operational framework. It moves IT teams beyond manual firefighting and reactive approaches, enabling a future where systems manage themselves, learn from experience, and continuously improve. Ultimately, generative AI transforms IT operations into a proactive, intelligent, and resilient environment. It ensures optimal performance, strengthens security, and accelerates innovation while reducing operational costs. As organizations navigate digital first demands, generative AI becomes a critical pillar for sustaining growth, ensuring ensuring reliability, and unlocking the full potential of autonomous IT. Now, the next slide is about reinforcement learning for autonomous IT. Reinforcement learning is becoming a foundational technology for autonomous IT operations as organizations move toward systems that can adapt, optimize, and correct themselves in real time. Reinforcement learning enables machines to learn through continuous interaction with IT environments, making decisions based on feedback and improving performance with each iteration. Instead of relying solely on predefined rules or static automation scripts, our reinforcement learning based systems evolve dynamically, learning the optimal actions to maintain reliability, efficiency, and stability in complex IT infrastructures. In autonomous IT ecosystems, reinforcement learning agents observe the state of infrastructure, servers, applications, networks, databases, security controls, and take actions that drive the system toward desired outcomes. These outcomes might include reducing latency, balancing workloads, preventing failures, or enhancing resource utilization. Over time, the reinforcement learning agent identifies which actions produce the best results and builds a policy that improves autonomously. This adaptive learning capability is essential in 2025, where environments change rapidly and workloads fluctuate unpredictably. Reinforcement learning plays a critical role in intelligent resource optimization across cloud and hybrid environments. By analyzing utilization patterns, performance metrics, and workload behavior, reinforcement learning can make real time decisions on auto scaling, load distribution, and capacity allocation. Unlike traditional threshold based scaling, reinforcement learning continuously evaluates the impact of its actions, ensuring optimal resource use while minimizing operational costs. This approach allows organizations to maintain service level agreements even during peak load events or sudden traffic surges. In predictive maintenance, reinforcement learning enhances system resilience by learning to anticipate failures before they occur. By experimenting with different policies such as moving workloads, rebooting components, or adjusting configurations, reinforcement learning determines the best course of action to maintain uptime. These self correcting behaviors reduce downtime, prevent cascading failures, and ensure mission critical applications remain available and responsive. Reinforcement learning also strengthens automated incident response. Reinforcement learning agents can be trained to detect anomalies, apply remediation actions, and verify the results, all without human intervention. Over time, the system becomes more effective as it learns which solutions resolve which types of issues. This reduces mean time to repair, improves reliability, and frees IT teams from repetitive troubleshooting tasks. Reinforcement learning driven remediation brings true self healing capabilities to IT environments. In development operations, workflows, reinforcement learning optimizes deployment strategies by learning from past successes and failures. It evaluates the outcomes of different deployment methods, tests, configurations, and delivery timings to minimize errors and maximize stability. Reinforcement learning can also tune CI and CD pipelines by adjusting test selection, optimizing build resources, and reducing bottlenecks. This accelerates release cycles while maintaining high quality and reducing deployment risk. Network management benefits significantly from reinforcement learning as the technology optimizes routing, bandwidth allocation, and congestion handling. Reinforcement learning agents adapt to real time conditions, ensuring that data flows efficiently even during unexpected spikes or failures. In distributed and edge environments, reinforcement learning becomes essential for coordinating resource decisions across devices that operate independently yet require consistent performance and security. Security operations are also enhanced by reinforcement learning's adaptive capabilities. Reinforcement learning systems learn optimal responses to threats, testing various mitigation strategies, and reinforcing those that minimize risk. This dynamic defense model is far more effective than static rule-based systems, especially as cyber threats continue to evolve. Reinforcement learning can adjust firewall rules, detect deviations from normal behavior, and autonomously quarantine suspicious activities, ultimately strengthening overall resilience. In IT service management, reinforcement learning optimizes ticket routing, automation triggers, and workflow prioritization. It learns from historical patterns to predict the fastest and most effective way to resolve issues, improving service quality and reducing operational costs. Reinforcement learning driven chatbots and virtual assistants also refine their responses over time, providing more accurate and context aware solutions to users. By 2025, the rapidly growing complexity of IT ecosystems makes traditional management methods insufficient. Reinforcement learning provides the adaptive intelligence required to manage dynamic systems at scale. Its ability to learn from experience, adjust policies, and optimize outcomes without human intervention makes RL a cornerstone for achieving fully autonomous IT operations. Ultimately, reinforcement learning drives IT environments toward self optimization, self healing, and self protection. It empowers organizations to maintain high performance, improve reliability, reduce costs, and accelerate innovation. As businesses become increasingly digital first, reinforcement learning serves as a key enabler for resilient, intelligent, and future ready IT operations. Now, the next slide is about Python programming language and R programming language. So first, I am going to make you all familiar with Python programming language. Python is the language of choice for modern analytics, AI, and software development. Its clean syntax makes it accessible to beginners and powerful for experts. Python's versatility spans data analytics, web development, automation, and AI applications. Pandas and NumPy enable fast, efficient manipulation of structured and numerical data. SciPy and stats models provide advanced statistical and scientific computing tools. Matplotlib and Seaborn create clear, informative static visualizations for reporting. Plotly, Altair allow interactive dashboards and web-ready visualizations. Python integrates seamlessly with scikit-learn for predictive modeling and machine learning. TensorFlow and PyTorch power deep learning, neural networks, and AI research. Jupyter Notebooks and Jupyter Lab combine code, visualization, and narrative in one platform. In finance sector, Python drives algorithmic trading, portfolio optimization, and risk analysis. Retail uses Python for customer segmentation, demand forecasting, and recommendation engines. Healthcare leverages Python for predictive diagnostics, bioinformatics, and imaging analysis. Big data processing is supported via PySpark, Dask, and Hadoop. For scalable analytics, ETL automation is simplified with Airflow and Prefect for robust workflows. Flask and Django enable web applications, APIs, and microservices for enterprises. Streamlit and Dash turn Python scripts into interactive dashboards instantly. Cloud integration with AWS, Azure, and Google Cloud ensures scalable deployment. Python automates reporting, notifications, and monitoring to save time and reduce errors. Package management with pip and conda ensures modular, maintainable projects. Python strong documentation and global community support rapid learning and innovation. Open source contributions drive continuous improvement and cost effective solutions. Educational institutions teach Python to build coding, analytics, and AI skills. Geospatial analysis is powered by GeoPandas and Folium for mapping and visualization. 3D modeling and simulations use storage and retrieval. Data storytelling combines visuals, interactivity, and analytics in a single workflow. Scientific computing benefits from Python in physics, biology, and engineering research. Rapid prototyping and agile development are natural with Python's lightweight syntax. Web scraping with Beautiful Soap and Scrappy allows automated data collection. Cybersecurity applications include threat detection, automated testing, and monitoring. Cross-platform compatibility ensures smooth deployment on Windows, Mac OS, and Linux. Python unifies data processing, AI, visualization, and automation in one ecosystem. Its simplicity, flexibility, and scalability makes it the universal language of modern analytics. Python drives innovation in AI, cloud computing, real-time analytics, and data engineering. Its growing ecosystem and active community secure its place for developers, analysts, and researchers. Python is not just a language, it is a tool for transforming data into insight, action, and value. Now, next I'm going to make you all familiar with R programming language. R remains one of the most powerful languages for data analysis, statistics, and visualization. Its syntax is designed for statistical computing, making it ideal for analysts and researchers. R provides a vast ecosystem of packages that extend its capabilities across industries. Across industries, data manipulation is streamlined with packages. Data manipulation is streamlined with packages like DP, LYR, and data.table for efficient workflows. Tidyverse unifies data cleaning, transformation, and exploration under a consistent framework. Visualization is one of our strongest suits, with ggplot2 providing elegant layered graphics. Shiny allows analysts to create interactive web applications and dashboards with ease. Plotly for R adds interactivity and real-time data visualization capabilities. R integrates smoothly with machine learning packages such as Carrot, MLR3, and Tidy models. Advanced AI and deep learning are supported via interfaces to TensorFlow, Keras, and Torch. R Markdown and R notebooks combine code results and narrative for reproducible research. In finance sector, R powers portfolio optimization, risk modeling, and algorithmic strategies. Retail analytics leverages R for customer segmentation, demand forecasting, and sales insights. Healthcare uses R for clinical trial analysis, predictive diagnostics, and bioinformatics. Big data processing is possible through Spark R and integration with Hadoop ecosystems. ETL and automation pipelines can be built using R scripts and workflow packages. Interactive dashboards and applications are deployed with Shiny server or cloud-based hosting. Time series analysis is streamlined with Forecast, Prophet, and Symbol packages. R's statistical modeling capabilities enable linear, non-linear, and mixed effects models. Spatial and geospatial analysis is supported via SF, SP, and Leaflet for mapping solutions. Data storytelling is enhanced through R's visualization reports and interactive outputs. Natural language processing in R is supported through tidy text and text mining packages. R connects with SQL and NoSQL databases for structured and unstructured data analysis. Simulation, Monte Carlo methods, and stochastic modeling are native strengths of R. R is cross-platform and runs smoothly on Windows, Mac OS, and Linux systems. Package management via CRAN and Bioconductor ensures access to thousands of libraries. Reproducibility is at R's core through scripts, R Markdown, and project-oriented workflows. Automation scripts can handle reporting, alerts, and scheduled analysis efficiently. R's open source nature drives continuous innovation and community support. Academia widely uses R to teach statistics, data science, and analytical reasoning. Visualization extends to 3D plotting, interactive maps, and network graphics in R. R supports integration with APIs, cloud computing, and modern data pipelines. Its flexibility allows analysts to move from data cleaning to advanced modeling seamlessly. Shiny and Flex dashboard enable rapid deployment of interactive applications. Data visualization, modeling, and storytelling are unified within a single R workflow. R's ecosystem and statistical foundations make it indispensable for data-driven insights. Its combination of analytical rigor, visualization power, and community support ensure longevity. R continues to evolve, powering analytics, research, AI, and decision making across sectors. R is not just a language, it is a statistical powerhouse transforming data into actionable insights. Now, the next slide is about generative modeling. Generative modeling is a core branch of artificial intelligence focused on learning the underlying patterns, structures, and relationships within data to create entirely new outputs that resemble the original data set. Unlike traditional predictive models that simply classify or estimate values, generative models simulate the data distribution itself. This enables them to produce realistic text, images, audio, code, and even complex simulations. By understanding how data is generated, these models can produce novel outputs that maintain coherence, accuracy, and contextual relevance. Generative modeling relies heavily on deep learning frameworks such as variational autoencoders, generative adversarial networks, autoregressive transformers, diffusion models, and normalizing flows. Each architecture approaches generation differently, but all share a common goal to learn a representation of data that can be sampled to create new high quality content. This capability allows generative models to act as engines of creativity, automation, and problem solving across industries. One of the most powerful aspects of generative modeling is its ability to learn from high dimensional, unstructured data images, natural language, audio signals, and sensor outputs. Instead of manually engineering features, generative models discover latent representations that describe the essential structure of the data. These latent spaces can be manipulated to produce variations, combinations, and entirely new forms of content. This flexibility makes generative modeling a foundational technology for modern AI powered creativity and analytics. In enterprise environments, generative modeling automates content creation workflows that once required significant manual labor. It can generate synthetic training data, create product designs, draft documents, and simulate business scenarios. These capabilities accelerate innovation, reduce operational overhead, and ensure consistency across large scale processes. With the ability to produce endless variations, generative models also enable personalization at scale in marketing, customer experience, and digital product development. Generative modeling plays a critical role in simulation based optimization and decision support. Models can simulate network performance, IT infrastructure behavior, financial market trends, and manufacturing processes. These simulations allow organizations to test hypotheses, predict future outcomes, and evaluate strategic decisions without risking real world consequences. This is especially valuable in IT operations where generative models can simulate system behaviors, failure patterns, and workload scenarios to support autonomous decision making. In cybersecurity, generative modeling is used to produce threat scenarios, detect anomalies, and stress test systems. By understanding normal system behavior, generative models can identify deviations that indicate potential attacks or vulnerabilities. They can also synthesize adversarial examples to strengthen defenses and train more resilient detection systems. This helps organizations stay ahead of evolving threats and build more adaptive, intelligent security frameworks. Generative modeling enhances R&D across scientific fields. In medicine and biotech, models generate molecular structures, predict protein folding, and simulate drug interactions. In engineering and manufacturing, generative design tools create optimized shapes, layouts, and prototypes that outperform traditional designs. These innovations reduce time to market and lead to breakthroughs in performance, efficiency, and sustainability. In IT operations, generative modeling supports autonomous systems by producing predictive insights, simulating resource needs, and generating remediation strategies. Generated scenarios help reinforcement learning agents train in safe, simulated environments. Synthetic logs, configurations, and incident patterns improve observability tools and strengthen predictive maintenance solutions. This makes generative modeling a foundational layer for building truly self healing, self optimizing IT ecosystems. Generative modeling also improves data privacy through synthetic data generation. Instead of sharing sensitive data sets, organizations can use generative models to produce realistic but anonymized data that maintains statistical value without exposing identities. This enables secure collaboration, compliance, and innovation across regulated industries like healthcare, finance, and government. Now, the next slide is about PyTorch with high sorry the automatic differentiation engine autograd track operation track autograd tracks operations and computes gradients automatically, eliminating the complexity of manual derivative calculation. This automation accelerates development and ensures mathematical accuracy across deep learning workflows. The PyTorch ecosystem provides a comprehensive suite of tools for building state-of-the-art models. Torque Vision, Torque Audio, and Torque Text offer pre-built datasets, transformations, and neural network components for vision, audio, and NLP tasks. PyTorch Lightning and Hugging Face transformers expand its capabilities with high-level abstractions, distributed training, and access to thousands of pre-trained models. These tools reduce boilerplate code and make complex model development significantly more efficient. PyTorch is also central to the development of generative AI. Diffusion models, GANs, large language models, and multimodal systems are often implemented using PyTorch due to its flexibility and performance. Researchers rely on PyTorch to experiment with new architectures, optimize training loops, and deploy large-scale generative models across distributed GPU clusters. This has accelerated breakthroughs in image generation, text synthesis, simulation, and scientific discovery. In reinforcement learning, PyTorch provides dynamic computation, fast tensor operations, and flexible model definitions that are essential for environments where actions and states change rapidly. Libraries like Stable, Baselines, 3, RLlib, and CleanRL build on PyTorch to provide sophisticated reinforcement learning algorithms for robotics, autonomous systems, and adaptive IT operations. This makes PyTorch a central platform for developing intelligent self-learning agents. PyTorch also supports enterprise-grade deployment through TorchServe, ONNX compatibility, and optimized runtimes for mobile and edge devices. Organizations can train models in research environments and deploy them across production systems with minimal friction. The ecosystem supports distributed training across multiple GPUs and nodes, enabling large scale deep learning projects that power real time analytics, predictive systems, and intelligent automation. In data science and IT operations, PyTorch is used to build predictive models, anomaly detectors, and optimization systems. Its ability to model complex patterns and behaviors helps organizations understand infrastructure performance, forecast resource needs, and detect risks before they impact services. When paired with generative modeling and reinforcement learning, PyTorch becomes a foundational tool for building autonomous IT systems that learn, adapt, and self-correct. PyTorch's open source community drives its rapid evolution. Thousands of contributors continuously enhance the framework and optimize the kernels, improve usability, and publish state-of-the-art models. This global collaboration ensures that PyTorch remains at the forefront of innovation and supports emerging AI trends across industries. By 2025, PyTorch has become essential for building AI that is flexible, scalable, and production ready. Its combination of research-friendly design, industry-grade performance, and expensive ecosystem positions it as a cornerstone of modern machine learning. Organizations rely on PyTorch to explore new ideas, build intelligent systems, accelerate digital transformation, and unlock the next generation of AI-driven innovation. Ultimately, PyTorch transforms how teams build and deploy AI solutions. It empowers researchers to push the boundaries of what AI can achieve and gives enterprises the tools to operationalize intelligence at scale. As AI driven systems become more autonomous, adaptive, and generative, PyTorch continues to be the foundation enabling these breakthroughs. Now, the next slide is about LLMs. Large language models are transforming AI operations by bringing advanced reasoning, natural language understanding, and powerful generative capabilities into IT operations. As IT environments grow increasingly complex, spanning multi-cloud, hybrid infrastructure, distributed applications, microservices, and edge computing, traditional monitoring and rule-based automation are no longer enough. LLMs enable AI operations platforms to interpret massive volumes of logs, metrics, and events, converting raw machine data into actionable intelligence that improves reliability, stability, and performance across the entire IT ecosystem. LLMs excel at understanding unstructured data, which forms the majority of IT operations information. System logs, configuration files, alerts, runbooks, chat transcripts, and documentation all contain valuable insights, but manually analyzing them is time consuming and error prone. LLMs can read, summarize, and correlate these data sources in real time, surfacing root causes, identifying anomalies, and providing context that accelerates incident resolution. This shift from manual investigation to AI driven analysis reduces operational burden and significantly lowers mean time to detect and mean time to resolve. In incident management, LLMs automatically interpret alert storms, cluster related events, and generate human like explanations and what is happening and why. They produce incident summaries, remediation suggestions, and next step recommendations, guiding engineers through complex troubleshooting scenarios. LLMs can even generate and execute commands in controlled environments, enabling partial or fully autonomous remediation. This brings self healing capabilities closer to reality, making operations more resilient and less reactive. LLMs also improve observability by analyzing patterns across logs, metrics, and traces. Instead of relying solely on predefined thresholds or static rules, LLMs adapt to evolving baselines and understand contextual changes in system behavior. They detect subtle anomalies, performance degradations, and misconfigurations that traditional tools might overlook. By correlating this information with historical incidents, knowledge bases, and configuration states, LLMs can predict potential failures before they disrupt services. In development operations pipelines, LLMs streamline CI and CD processes by reviewing code, generating test cases, analyzing deployment plans, and predicting rollout risks. They help teams identify dependencies, detect configuration drift, and evaluate potential impacts before changes reach production. LLM driven insights reduce deployment errors, accelerate release cycles, and enhance the overall quality of software delivery. By integrating with version control systems, LLMs create detailed documentation, architectural diagrams, and change logs automatically. LLMs play a significant role in IT service management as well. They power intelligent virtual agents capable of resolving routine tickets, providing guided troubleshooting, and automating back-end workflows. These systems interpret user intent, classify requests accurately, and fetch relevant knowledge articles without human intervention. LLM-enabled ticket analysis uncovers recurring issues, identifies knowledge gaps, and suggests improvements to IT processes. This reduces support queues and improves end user satisfaction. Security operations also benefit from LLM integration. LLMs analyze threat intelligence, feeds, interpret security logs, and summarize attack patterns, enabling faster threat detection and response. They compare system behavior against known vulnerabilities, generate incident reports, and even help create automated playbooks. By correlating signals across infrastructure, LLMs provide richer context that strengthens defenses in an increasingly hostile cyber landscape. For capacity planning and resource optimization, LLMs analyze historical data, forecast future demand, and recommend efficient allocation strategies. They simulate what if scenarios and evaluate how configuration changes might affect system performance. This proactive intelligence helps organizations minimize waste, optimize cloud spending, and maintain consistent service level agreements. By 2025, the complexity of modern IT systems makes LLMs indispensable for AI operations. Traditional monitoring and manual analysis cannot keep pace with rapidly evolving applications, distributed architectures, and large-scale data flows. LLMs introduce a layer of intelligent automation that understands, explains, and optimizes IT operations with human-like reasoning. They enable IT teams to move from reactive firefighting to strategic proactive operations. Ultimately, LLMs elevate AI operations into a new era of autonomous intelligence. They support self-healing infrastructure, accelerate incident resolution, enhance system reliability, and reduce operational costs. As enterprises depend more on digital services, LLM-driven AI operations become a critical enabler for maintaining performance, ensuring resilience, and driving innovation across the entire ecosystem. Now, the next slide is about Ansible for autonomous infra. Ansible is emerging as a critical automation engine for building autonomous infrastructure, enabling organizations to manage complex systems with consistency, intelligence, and minimal human intervention. As IT ecosystems expand across hybrid cloud, multi-cloud, on-premises, and edge environments, infrastructure teams require tools that can orchestrate configurations, enforce compliance, and execute workflows at scale. Ansible's declarative approach, agentless architecture, and powerful automation capabilities make it an essential foundation for delivering autonomous, self-configuring, and self-healing infrastructure. At its core, Ansible simplifies infrastructure management through human-readable playbooks, enabling teams to define desired system states rather than writing complex procedural scripts. This declarative model ensures infrastructure remains predictable, repeatable, and aligned with policy-driven goals. In autonomous environments, Ansible acts as the execution layer that translates high-level AI or policy recommendations into standardized automated actions that maintain stability and quality. Ansible integrates seamlessly with AI operations, LLM-driven analysis, and reinforcement learning systems. As intelligent platforms detect anomalies, configuration drift, or performance degradation, Ansible can automatically apply remediations in real time. This turns insights into action, closing the loop between detection, decision making, and execution. Automated patching, configuration fixes, load balancing adjustments, and service restarts become part of a self-healing infrastructure that operates without manual intervention. One of Ansible's strengths is in autonomous infrastructure is its ability to orchestrate end-to-end workflows across diverse systems. Whether deploying applications, provisioning compute resources, configuring networks, or enforcing security baselines, Ansible ensures each step is executed reliably across thousands of nodes. Its modular structure and vast collection of certified roles and modules allows teams to automate virtually every aspect of infrastructure operations, reducing operational complexity and the risk of human error. Ansible also enhances governance and compliance in dynamic environments where configurations change rapidly. Maintaining consistency, security, and operational standards becomes challenging. Ansible automation platform enables continuous compliance by automatically enforcing policies and validating infrastructure states. Playbooks can detect unauthorized changes, revert incorrect configurations, and maintain audit-ready infrastructure even as systems evolve. This ensures organizations remain compliant with industry frameworks and regulatory requirements without extensive manual oversight. In cloud environment, Ansible plays a critical role in provisioning, scaling, and managing distributed workloads. It automates resource deployment across AWS, Azure, Google Cloud, and private cloud platforms, ensuring infrastructure adapts to business demands. In autonomous environments, AI-driven systems can trigger Ansible workflows to scale resources, optimize configurations, or migrate workloads proactively, enhancing performance and cost efficiency. For development operations teams, Ansible accelerates CI and CD pipelines by automating environment creation, deployment steps, and post-deployment verifications. This not only shortens release cycles but also ensures consistent environments across development, staging, and production. When combined with LLMs or reinforcement learning agents, Ansible can dynamically adjust deployment strategies, roll back problematic updates, and optimize application delivery with minimal manual intervention. Ansible's agentless nature gives it a unique advantage in large scale or distributed environments without the need to maintain local agents. Organizations reduce overhead, improve security, and simplify operations. This architecture supports rapid scaling as Ansible can execute changes across thousands of systems using secure built-in SSH communication. In edge environments where lightweight autonomous operations are essential, this provides a powerful model for managing diverse devices remotely and reliably. In IT service management, Ansible powers autonomous workflows that streamline ticket resolution, automate routine operations, and enforce service level policies. As AI platforms categorize tickets or detect recurring issues, Ansible can instantly trigger corrective actions, reducing backlogs and improving the speed of service delivery. This contributes to an intelligent, proactive operations framework where issues are resolved before they impact users. By 2025, the growing complexity of IT ecosystems makes manual infrastructure management unsustainable. Ansible delivers the automation, consistency, and extensibility required to support autonomous operations at scale. It provides the execution framework that ties together AI driven insights, predictive analytics, and policy automation into a cohesive, self managing infrastructure. Ultimately, Ansible transforms infrastructure into a reliable, adaptive, and intelligent ecosystem. It empowers organizations to operate with higher efficiency, enforce stronger security, and support continuous innovation. As digital first strategies accelerate, Ansible becomes a cornerstone technology for building autonomous infrastructure that is resilient, scalable, and future ready. Now, the next slide is about career roadmap. Imagine starting your career in IT or AI without a roadmap. It is like sailing in a vast ocean without a compass. The first step is understanding where you want to go. Are you drawn to cloud computing, AI, data science, cybersecurity, or IT operations? Once you know your destination, building a solid foundation is essential. Learning the basics of networking, programming, Linux, and cloud platforms because these skills become the tools you will rely on every day. Certifications in AWS, Azure, or Google Cloud act like milestones or on your journey, proving your skills and opening doors. Programming languages such as Python, Java, or Go are your language of navigation. They let you interact with systems, automate processes, and bring AI models to life. Automation tools like Ansible, Terraform, and CI and CD pipelines help you work smarter, not harder, streamlining repetitive tasks so you can focus on innovation. Diving into AI and machine learning introduces you to a world of possibilities from predictive analytics to generative AI and reinforcement learning. Hands on experience with frameworks like PyTorch or TensorFlow turns theory into action, while real world projects teach you how to solve complex problems creatively. Contributing to open source projects builds both your reputation and your confidence, while learning observability and AI operations equips you to monitor and optimize entire infrastructures. Cloud native architectures, containerization, and microservices prepare you to manage scalable, resilient systems, while cybersecurity knowledge ensures your work is secure and compliant. Developing leadership, communication, and collaboration skills is just as important as technical expertise. They help you guide teams and drive projects forward. Staying curious about emerging trends like autonomous IT, generative modeling, and self-healing systems keeps you ahead of the curve. Networking through webinars, communities, and professional forums expands your opportunities and connections. Continuous learning is not optional, it is how you remain relevant in a fast changing industry. Following a structured roadmap transforms uncertainty into clarity. It guides you from a beginner finding their footing to an expert making strategic, impactful contributions. Ultimately, your career becomes more than a series of jobs. It becomes a journey of growth, innovation, and leadership in the world of IT and AI. Now, the next slide is about top certifications. Imagine standing at the crossroads of your IT or AI career, wondering which path will take you to the top. One of the most powerful tools you can carry is professional certification. It is like a passport that proves your skills and opens doors to new opportunities. In cloud computing, certifications like AWS Certified Solutions Architect, Microsoft Azure Fundamentals, and Google Cloud Professional Cloud Architect show that you can design and manage scalable, reliable cloud infrastructures for IT operations and automation. Credentials such as Red Hat Certified Engineer, Ansible Automation Specialist, and VMware Certified Professional signal that you can keep complex systems running smoothly. Cybersecurity is another critical frontier, and certifications like CISSP, CEH, and CompTIA Security Plus demonstrate your ability to protect systems against growing threats. If AI and data are your passion, Microsoft certified Azure AI engineer, TensorFlow developer, and IBM AI enterprise workflow certifications validate your ability to build intelligent, impactful solutions. Machine learning and data science certifications, including Google Professional Data Engineer and AWS Machine Learning specialty, prove you can turn raw data into actionable insights. Development operations certifications like Docker certified associate, Kubernetes administrator, and Jenkins engineer highlight your skills in automation, continuous integration, and rapid delivery. Networking credentials such as Cisco, CCNA, and CompTIA Network Plus show mastery of the infrastructure that keeps digital systems connected. IT service management certifications like ITIL teach frameworks for improving efficiency and service quality. Emerging certifications in AI security, autonomous IT, and cloud native operations prepare you for the technologies of tomorrow. Programming certifications such as Python, CAP, or Java SE programmer ensure your coding skills meet industry standards. Every certification you pursue builds credibility, demonstrates commitment, and boosts confidence. Together, they signal to employers that you are ready to tackle complex problems, lead projects, and innovate at scale. By strategically choosing top certifications, you are not just adding credentials, you are shaping a career that is future ready, impactful, and full of opportunity. And now the last slide is about conclusion. As we wrap up today's session, it is clear that IT and AI landscape is evolving faster than ever before. Intelligent IT is no longer a luxury, it is a necessity for organizations striving to stay competitive. Automation, AI, and advanced analytics are transforming IT operations from reactive to proactive. Self-healing systems, predictive maintenance, and autonomous decision making are now within reach. Generative AI has opened new avenues for creativity, automation, and intelligent problem solving. From generating content to optimizing workflows, its impact is reshaping enterprises across industries. Reinforcement learning equips IT systems with the ability to learn from experience, adapt, and optimize continuously. Autonomous IT operations powered by reinforcement learning minimize human intervention and enhance operational efficiency. Generative modeling forms the foundation of intelligent AI systems, enabling realistic simulations and predictive insights. It allows organizations to experiment safely, optimize designs, and explore scenarios without risk. PyTorch serves as a backbone for AI development, supporting research and production deployment. Its dynamic computation and extensive ecosystem make it ideal for building cutting-edge models. Large language models in AI operations take observability and incident management to the next level. They analyze unstructured data, detect anomalies, and provide actionable intelligence in real time. Self-driving IT operations become feasible with LLM-guided automation and predictive insights. Ansible brings these intelligent insights into action, automating infrastructure and ensuring consistent operations. Declarative playbooks and agentless architecture make managing complex environments efficient and reliable. Autonomous infrastructure is no longer a vision, it is an achievable reality with AI driven orchestration. A clear career roadmap is essential to navigate this rapidly evolving landscape. Focusing on foundational skills, hands on projects, and continuous learning ensures long term growth. Certifications in cloud, AI, cybersecurity, DevOps, and networking validate expertise and accelerate career progression. They provide credibility, open doors, and prepare professionals for leadership roles. The convergence of automation, AI, and analytics transforms IT from a cost center into a strategic enabler. Organizations gain measurable benefits in efficiency, reliability, and innovation. By embracing intelligent systems, enterprises can reduce downtime, optimize resources, and scale effectively. Predictive analytics, generative AI, and reinforcement learning empower teams to make smarter decisions. Real time monitoring and autonomous remediation ensure high service availability and improved user experience. Security is strengthened through automated threat detection, risk analysis, and compliance enforcement. Hybrid and multi cloud environments are managed efficiently with intelligent orchestration and AI driven workflows. Continuous learning from data allows IT systems to evolve, becoming smarter and more adaptive over time. Intelligent IT and AI are no longer separate functions, they are integrated enablers of business innovation. Organizations that adopt these technologies gain strategic advantages and maintain competitiveness. The combination of predictive insights, automation, and generative capabilities drives resilience and agility. AI-powered analytics uncover hidden inefficiencies and opportunities across operations and infrastructure. Employees are freed from repetitive tasks and can focus on high-value strategic initiatives. Digital transformation is accelerated and enterprises are positioned to innovate faster than ever. By 2025, autonomous intelligent IT will be critical not only for operations but for enterprise-wide growth. Embracing this future ensures organizations remain adaptable, proactive, and resilient in a digital-first world. Ultimately, the synergy of AI, automation, and human expertise transforms IT into a true driver of business success. The journey toward intelligent IT, generative AI, and autonomous systems is ongoing, but the path is clear. By investing in skills, technologies, and certifications today, professionals and organizations secure their place in the future of innovation. So that's all for today. Thank you for listening to me patiently. Let's meet in the next webinar.